The last type of circuit we're going to need to be able to analyze in this class is what's known as a complex circuit. This is an example of a complex circuit right here, and you can probably see immediately why this is considered a complex circuit. It's not quite in series, it's not quite in parallel, it's a combination of both. So in this case, I have an 8 ohm resistor and a 3 ohm resistor, which are wired in series. If I'm an electron, I pass through each of them one after the other. I also have an 8 ohm and a 7 ohm wired in series, but at the same time, I have a 3 ohm and a 7 ohm wired in parallel. So it's a complex circuit because some of the elements are wired in series and some are wired in parallel. It all depends on which pathway is chosen. So in order to analyze these, it's a little bit more complicated, but we're going to use the same general method with a few additional rules or a few additional laws. So the first step to analyze any kind of complex circuit is just like every other problem we've looked at. You should draw one of your tables and list all of the given information. So in this case, I've decided to call the 8 ohm resistor R1, the 3 ohm resistor R2, and the 7 ohm resistor R3. So I've listed my resistance values as well as the total voltage, which is 110 volts. So at this point, no different than what we've looked at previously. Step 2 is to calculate the total resistance. Again, the same step. However, because we have a series or two series wirings and one parallel, it becomes a little bit more complicated. The tip I can recommend is it's generally easier to get rid of your parallel or define the total resistance by combining your parallel first. And what I mean by that is if I want to decide to wire these in series, well, if I just add the 8 and the 3, well, afterwards, when I've added that and gotten 11 because it's in series, do I connect it with this section of the circuit that goes back to the battery? Do I connect it with the 7 ohm resistor? You run into a problem because you have two different pathways. You can only connect it to one of them. So that presents an issue. So what we'd like to do is kind of combine these and figure out what would the total resistance of these two together be. So because they're in parallel, I just add them to the -1. So 3 to the -1 plus 7 to the -1 gives me a value. And if I raise that value to the -1, I get 2.1 ohms. So what that means is these two together act as a 2.1 ohm resistor. So this little this little circuit here is really no different than this one in terms of like the amount of current and all that. So in this case, by combining those two, I haven't physically combined them, but by analytically combining them, it's like having an 8 ohm resistor and a 2.1 ohm resistor that are now in series. So once I've kind of combined these, I can then add it to the 8 because that's now in series with the 8. So my total resistance in this case is 10.1 ohms. I combine these first, and by combining them analytically into a 2.1 ohm resistor, I now have 10.1 ohms, as this is now a series circuit analytically. I haven't physically changed the circuit in any way. But by combining the parallels first, that will probably help you 95% of the time. There's a few cases where we might have to do like the series components first, but we'll get to those problems later. So now that I have my total resistance, I will go ahead and I will place it in the chart, and I should be able to calculate one of these quantities. In this case, I have the resistance and the voltage for the circuit. So using Ohm's law, I can now find that the current is 10.89 amps. So the only difference so far is that the complexity is increased, so I have to combine the parallel first, and then I can combine it with the original R1 resistor, and now I move forward. I have my current of 10.89. Here's where it gets a little bit tricky. In order to figure out what the current in each branch is, we have to use what are known as Kirchoff's rules. They tend to be a little bit complicated, so I've tried to break them down into a method that is as simple as I can possibly break it down into. And it goes like this. So we know from our original calculation that 10.89 amps of current leaves this side of the battery. Well, there's only one pathway, so it's going to also, all 10.89 will travel through here, 10.89 will travel through R1, and then we'll travel through this section. It's not until we hit this junction where that current will split. So for R1, I'm going to have all 10.89 amps because that current has no other choice. Every single electron that leaves that battery must travel through R1. So all 10.89 amps will travel through R1. Now figuring out exactly how much will split, that comes down to Kirchhoff's rule. So what I've done is I've taken this section of the circuit here. This section's still here, but I've taken this section and decided to highlight it so you guys can understand what I'm doing. So we know that 10.89 amps is what's traveling and hitting this junction. So the way we can figure out how much current is in each is we take the largest value resistor. If there was 5 branches, same thing. You just choose the highest value resistor. And we call that X. X represents the unknown quantity of current that travels in this branch. Well, if I divide 7 by 3, well, that tells me that 7 is 2.33 times larger than 3, which tells me that this branch is 2.33 times more resistive. It has 2.33 times more resistance to flowing charges. By knowing that, I can realize that this one, which has less resistance, will have 2.33 times more current. So what we've effectively done is said, well, if this is the current in this leg, this current will have to be 2.33 times larger because technically 3 is 2.33 times smaller than 7. And an electron will always want to take the path of least resistance. So if you take your largest value resistor and consider that x, you take your other legs and you just take that value and divide it. If I had 3 of them, let's say I had like a 7, a 3, and a 2, I would do the same method, but for this branch, I'd say 7 divided by 3. For the next branch, I'd say 7 divided by 2. And what you're basically setting up is a ratio. This one will have X amount of current. This will have 2.33 times that number because it has less resistance, and so on and so forth. So I know that 10.89 amps is going to split between these two. So all I have to say is 2.33 times whatever that amount of current is in this leg, plus whatever current is in this leg must equal my total of 10.89 amps. Just by solving through, I know that 2.33x plus x equals 3.33x, and then if I divide both sides by 3.33, I know that this unknown quantity must be 3.27. So that tells me that this leg has 3.27 amps of current, and this leg will have 3.27 times 2.33 amps of current. And that's all I've done down here. I've simply taken resistor 2, which will have 2.33 times that amount of current, which gives me 7.62, and R3 will have the 3.27 because that's what X is. So once I have the current in all my branches using Kirchoff's rules, it's just a matter of calculating your remaining variables. Once I have any two in a row, I can find the third, in this case voltage, resistance times current, and so on and so forth. Once you have those, if you ever wanted to double check, one quick way would be pretend you're an electron and pick a pathway. Well, I'm going to travel through R1, and then let's say I go through R2. Well, I've passed through R1 and R2. I must spend my 110 volts in their entirety. So R1 is 87.12, R2 is 22.86. When I add those together, I find I'll get 110 volts because that's what I spent to get through those two. Well, what if I didn't go through this pathway? What if I went through instead R1 and then R3? Well, I still have to spend my 110. I spent 87.12 at R1, 22.89 at R3, and once again, I will get 110 volts. These columns do not need to add up in complex circuits. You need to pick a pathway and make sure that you have spent all the voltage you began with. If this was about 87 and one of these was like 50, well, when I add those together, I get more than 110, and that would immediately tell me that I did something wrong. So complex circuits, again, a little bit more complicated, but if you pay careful attention, especially to Kirchoff's rules, it becomes significantly easier. So if you're lost on this, let me know.